This is the first episode of my new YouTube channel, Infinitesimal. Any fellow nerd that decides to click on this video will be treated to my best attempts at explaining concepts I learn about as a physics student. To introduce myself, your host, I am David Mukatash, an astrophysics major who is at the time of this video almost college level. This is my attempt at explaining what a wave is. Imagine the slithering of a snake, how the tail of the snake seems to curve left and right. Imagine that the head and tail end of the snake is always on the same straight line. It's just slithering with the head and tail end stuck in place. Now, while it's slithering, imagine you stop time if you could. Remember, it was still slithering when you stopped time, so its body is probably coiled or all curved. Now, draw a line straight through the snake so that you divide the snake into its top half and bottom half. Notice how it has curves that look like long half circles on the top and bottom halves. Now pick a point that lies on the line that divides it. Maybe the head of the snake? Now follow the path that the snake makes until it hits the straight line you drew. That path you just drew is exactly half a wave. Do the exact same thing again, start at where you ended, and keep going until you hit the line. That is a full wave. The distance this full wave covers across is called a wavelength, or the length of a full wave. Notice how it starts and ends at the same point. Notice how it looks like a pattern, one circle up and one circle down. Notice how, if you were to repeat that same pattern from the end of the path you drew, it would end up on the exact same line, only a larger distance away. Both waves drawn would look exactly the same. Notice how it looks like the letter S put on its side. What would it mean if that S stretched or pushed closer together? Now, the time it takes for a wavelength to finish from start to end is called a period. The time it takes for the snake to slither and complete one full wavelength is also technically a period, in this example. But what if it's a fast snake? What if it completes a full wavelength in a smaller amount of time? Then you could say that the wave has a large frequency. Frequency is a number of wavelengths the wave does in a given amount of time. Let's say a single second. So in a single second, this wave would probably complete a lot of full waves over a second. What about how large the circles are on the snake? How far do they stretch from the line you drew in the middle? That distance, or height, can be considered the amplitude of its wave. Amplitude increases as energy increases. It also decreases as energy decreases. So let's say that the snake was really tired. When slithering, the circles it makes wouldn't probably be all too far. It would most likely move in a super stretched S pattern because it's way too much effort to make all those loops and curves. In a similar way, a wave would have a smaller amplitude if it has less energy. It would have a larger amplitude if it has more energy. But what about frequency? What if the snake completed lots of waves, or full slithers maybe, in a second? Well, remember, a snake has a constant size. That snake isn't going to be any larger. Imagine the snake is a certain length. It cannot get bigger or smaller. If you wanted to curl that snake to make large, overarching curves, you would only make one wave. This snake isn't big enough to make multiple huge, long waves like that unless it grew a bunch more. But what if you wanted to make super big, short waves that have the same amplitude as the long ones? Think of a zigzag pattern or a super compressed S shape. Well, it takes a lot of distance to make a lot of those. If this snake could only make one wave while super stretched, the only way that it could make more at the same amplitude is if you decrease the wavelength. Now that each wave takes less distance, less of the snake is used up in making a single wave. But the plus side is you get more waves. This is the relationship between wavelength and frequency. You can have a lot of waves in a single period for that snake, but each added wave will sacrifice a bit of distance that the wave takes up. If you wanted a large distance, you wouldn't be able to complete very many waves without adding more length to that snake, which is impossible. The amplitude, frequency, wavelength, and period are all things that are important to waves. Amplitude represents the energy the wave has. Frequency represents the amount of waves that are completed in a second. A period is the time it takes for a single wave to be completed, and wavelength is the distance the waves travel from start to finish. Similarly, the amplitude of a snake is how far those curves go from the line we all drew. The frequency is how many of those curves that snake can have in a period of time. A period would be how fast that snake can finish a whole wave, and the wavelength is how far each full wave spans on the serpent's body. But there is one more crucial thing. Regardless of how big the curves are, or how many waves the snake can complete in a second, that snake will always move at the same speed. The speed the snake moves cannot change in this situation, so a change in wavelength or frequency has no effect on it, only on each other. As wavelength increases, frequency decreases, and the opposite is true as well.